The Indian Space Research Organization ISRO has successfully conducted a hot test of its semi-cryogenic engine power and power head at 88% of its target thrust, marking a key milestone in its propulsion development program. ISRO said that its test represents a significant step forward in advancing next-generation engine technology aimed at enhancing future launch vehicle capabilities. Brian Thomas joins us on the broadcast to give us more on this. Brian, take our viewers through the details that we have.
Sabri, clearly as of now, the Indian Space Research Organization has successfully carried out a hot test of the power head of its semi-cryogenic engine, achieving 88% of the engine's target thrust in a major technological milestone for India's next generation launch vehicle program. Not only that, according to ISRO, the successful test validates the performance of critical engine systems, including turbo pumps, pre-burner control systems, and even associated hardware under the real operation conditions. Not only that, this very achievement marks significant process in the development of the semi-cryogenic propulsion system, which is also rather expected to deliver higher performance, improved payload capabilities, and even greater efficiency for future space missions. And this successful test brings ISRO a step closer also to qualifying the engine for full-scale testing and eventually integrating into India's next-generation launch vehicles, strengthening the country's indigenous space capabilities and also long-term ambitions in satellite launches and deep space exploration. Yes.
For sharing all those details. Let's take a look at the details of the semi-cryogenic power head. What exactly do we know so far? We will be putting out all that information on our screens, but again, developments are taking place. We want to help you understand what the semi-cryogenic engine power head is. Let's quickly put out that information on our screens. Number one, the semi-cryogenic engine uses liquid oxygen and refined kerosene propellants for high thrust. That's number one detail that we're tracking as far as the energy is concerned. Number two, the engine offers higher thrust and better efficiency than current liquid stages. So again, a point about accuracy over there and why it makes it different, why it makes it better. Let's put out some more details on our screens. This new engine will replace existing boosters for enhanced space launch capabilities. So of course, the transition and therefore why it is that this is truly important. And number four on your screens, this powerful engine delivers 2,000 kilonewtons of thrust for heavy lift vehicles. A very pertinent detail there as far as the energy is concerned. 2,000 kilonewtons of thrust is what is anticipated and what's being delivered over here. This new power head will boost payload capacity of the LVM-3 rocket significantly. Again, why it is that this engine is really being looked at very closely and what makes it perhaps very different. Here another detail. The B technology combines a cryogenic oxidizer with storable hydrocarbon fuel effectively. So again, details of pertinence there as far as the semi-cryogenic engine power head is concerned. This technology combines cryogenic oxidizers with storable hydrocarbon fuel effectively. So again, that's what we were telling you about earlier as well. And that's what makes it different, that's what makes it special, and that's what makes it, really something that people are keeping their eyes peeled on. I'm going to get in a very important guest with us on the broadcast. Dr. Suresh Nayak, ex-Group Director of ISRO, joins us on the broadcast to give us his perspectives. So, appreciate you taking out time this afternoon, speaking to us on NewsX. A very important day indeed. Help our viewers understand the significance, of this achievement as far as the, this achievement in engine, the, milestones are concerned.
Yeah, actually, this achievement is very significant and really a high sort of a breakthrough achievement. You see, basically this technology of semi-cryogenic engine is available with very few nations, and India will become one of them after this successful test. Okay, now what is the difference between the semi-cryogenic engine and the normal cryogenic engine? Let us see that. In normal cryogenic engine, the propellant is liquid hydrogen and the oxidizer is liquid oxygen. Now, you see, in this particular case of semi-cryogenic engine, the propellant is refined kerosene and the oxidizer remains the same as liquid oxygen. So this significantly reduces the cost because liquid hydrogen really forms a large part of the propellant in the rocket, and this is going to be replaced by liquid kerosene. So this will reduce the cost. Secondly, this will also increase the thrust level. So the capacity to carry the payload means satellite will it be increased to 6 tons now. And this is very useful for our future space missions, and they will become economical. And also, this particular development will give a boost to the reusable rocket technology, as this is going to be a very useful thing for that purpose also. And secondly, this particular thing now actually when this liquid kerosene is used, that need not be at a very low temperature, unlike liquid hydrogen. Hydrogen remains gas unless it is cooled to a very low temperature like minus 70, minus 80 degrees Celsius. And otherwise, it will become gas and occupy more space. In case of kerosene, this question doesn't arise. So the insulation problem, etc., also are going to be simplified. Only in case of liquid oxygen, that particular technology of taking the oxygen to the very low temperature, cryogenic temperature, will be there. So that is going to be also another great advantage. Thank you.
Right, absolutely. So, also help our viewers understand, those to whom these are just the mere sentences, mere numbers. Uh, how significant does this development truly become as far as India's hope and wish is in order to explore the space much more?
Asking actually in numbers, what would be the number of flights, etc.?
Yes.
See, once this technology is mastered, actually this hot test was done at Mahendragiri, and there, this testing facility also is extremely complicated. So India has successfully developed that. See, now today, if you see the flights per year, which ISRO is able to launch, I'm talking about the heavy vehicles like LVM-3, not the PSLV or other smaller rocket launches. So in that case, I think we are launching about 6 flights, approximately, I'm saying, per year. And we are launching quite a few foreign satellites, and that gives a lot of revenue to ISRO because there is a huge market of satellite launching service in the world market, and India is trying to cash on it. Today, we are having just about 2% of that market. Now, that to be want to increase it to 10%, by about 230 or 232. And in that particular respect, also, this technology will be useful because you see, filling the liquid hydrogen in the rocket and trying to keep it at that low temperature, all these things will be simplified. And the number of flights we can increase. And that is also another advantage. Of course, the other thing also we'll have to keep pace with that. But basically, that is one of the most important thing of semi-cryogenic engine.